Welcome to the deep dive. Today, we're taking a deep dive into an industry that's kind of quietly powering the whole electric vehicle revolution. That's the e-drive testing solutions market. We've been looking through some excerpts from a market research report, and let me tell you, the scale of this growth, it's really something once you dig into the data. So our mission today is really to unpack all this fascinating data. We want to understand what these e-drive testing solutions actually are and figure out where this really high growth market is surging around the world. Okay, let's get into it.
Yeah, it's interesting. You probably don't think too much about the sophisticated tools they use to validate electric drivetrains,
Hmm.
but they are absolutely critical, really, for the performance, the efficiency, and of course the safety of every single EV out there. And what's fascinating to me is how the trajectory here, it isn't just like following the rise of electromobility. It's actually making it happen. It's fundamentally enabling it.
Right, enabling it. And when we talk about a high voltage growth trajectory, I mean, we're talking about some serious numbers here. According to the source material we have, the global market for these eDrive testing solutions, it was valued at just under $848 million back in 2021.
That's right. And it's projected to hit $1,368 million by 2025, but then it really takes off,
Yeah.
surging to an impressive $3,560 million, roughly, by 2033. So that's a compound annual growth rate, a CAGR, of 12.7%, which, if that holds, the market basically more than doubles every 6 years or so. That shows sustained, significant investment.
Wow. Okay, here's where it gets really interesting for me, and I'm kind of curious about this bit. This explosive growth, it's driven by two key things, right? The global adoption of EVs, obviously, and then the demand for these advanced, accurate, efficient tools to actually test the eDrive performance. So could you maybe elaborate a bit on how those two forces, how do they actually interact? How do they push this market forward together?
Yeah, absolutely. It's a dynamic interplay, really. So first, just think about the sheer explosion in EV adoption. As car makers go from making thousands of EVs to millions, they just they can't manually test every single drivetrain. It's impossible. They need automated systems, high throughput systems that can quickly validate thousands and thousands of units, but with real precision. Think of it like moving from handcrafting something to mass production, but you absolutely cannot compromise on quality or safety.
Okay, that makes perfect sense. So it's about speed, it's about volume. And that, I guess, leads straight into the second driver you mentioned, the demand for advanced, accurate, efficient tools. So what's actually changing in the technology itself? What are we talking about when we say e-drive testing solutions?
That's a great question. So when we talk about eDrive testing solutions, we're really talking about all the sophisticated equipment and software
Yeah.
that's used to rigorously evaluate the electric towertrain.
Yeah.
And that means, the motor, the inverter, the gearbox, checking them for performance, efficiency, durability, safety, all of it. And this can range, from huge dynamometers that simulate real-world driving conditions
Hmm.
to tiny, highly precise sensors measuring things like noise, vibration, harshness, NVH, they call it. And it even includes advanced simulation software, so you can test components virtually before you even build a physical prototype.
Right, virtual testing first.
Yeah, exactly. And we're seeing this fundamental shift, really, from sort of traditional mechanical testing towards more integrated, software-defined systems. I mean, EVs are essentially computers on wheels, right? So testing their drivetrains now involves really complex stuff like power electronics, thermal management, even cybersecurity aspects. And all that drives demand for these highly specialized tools that can simulate extreme conditions and just give you incredibly granular data on every performance metric you can think of.
Okay, wow. That paints a much, much clearer picture of the tech behind those big numbers. So, all right, we've seen the global picture. We understand the drivers a bit better now. Let's maybe zoom in. North America, obviously a powerhouse in automotive innovation. This region, their e-drive testing market hit, what, $324.78 million in 2021. And it's projected to rise to about 511, nearly $512 million by 2025. And then more than double again to 1.278 billion, let's say, by 2033. That's a CAGR of 12.125%. Pretty solid.
Yeah, very solid. And what really stands out there is how the United States just leads that growth. Their revenues are expected to climb from $222 million or so in 2021, way up to $835 million, nearly $836 million by 2033. And that's largely down to their strong domestic EV manufacturing base, right? Plus significant R&D investment. And just that general push towards electrification across all sorts of vehicles, passenger cars, even heavy-duty trucks.
Yeah, that makes sense. Okay, Canada's accelerating too, projected to reach about $316 million by 2033 with a key GR of 12.6%. But Mexico shows the fastest growth in the region. It's projected to climb from about $26.6 million in 2021 to $126.5 million by 2033. That's a CGR of almost 14%, 13.951%. Why Mexico specifically? Why is it accelerating faster even though it's starting from a smaller base?
That is some serious momentum, isn't it? Well, this accelerated growth in Mexico, it likely points to maybe new large-scale EV manufacturing hubs being set up there, or perhaps a big focus on exporting EV components globally from Mexico. When new production lines get established, you absolutely need robust local testing infrastructure right from the get-go, and that drives really rapid investment in these kinds of solutions.
Ah, okay. Building it from the ground up drives faster initial growth.
Gotcha. All right, so from those established markets in North America, let's cross the Atlantic. Europe. The European market for these solutions was valued at $172 million, roughly, in 2021, and it's estimated to reach about $684 million by 2033. That reflects a PRR of 12.2%, basically, pretty similar to North America overall. And among the European countries, the UK is actually forecasted to reach about $131 million by 2033. Germany's close behind, projected around $126.5 million. France also sees pretty significant growth, up to about $84 million by 2033. But if you sort of connect this to the bigger picture, yeah, these larger economies are key, obviously. But some smaller regions like Spain and Denmark, they're showing particularly high growth rates. 13.6% CAGR for Spain, 13.1% for Denmark.
Interesting.
Yeah, it suggests really broad-based adoption, probably fueled by, national incentives for buying EVs, plus strategic investments in maybe specialized manufacturing or R&D facilities in those countries. Even the sort of rest of Europe category is notably strong. A 15.3% CAGR. That really highlights this widespread commitment across the continent to electric mobility.
Wow. Okay. 15% for the rest of Europe is significant. Now, let's talk about Asia Pacific. This region is showing, well, just tremendous potential. And arguably, it's kind of defining the future trajectory of this whole market, wouldn't you say?
Oh, absolutely. It's huge.
Starting at almost $241 million in 2021, this market's expected to climb to over $1.1 billion by 2033. That's a CAGR of 13.6%, higher than North America or Europe.
Yeah, and if we connect that to the bigger picture of just global EV manufacturing, China's the undisputed regional leader here, forecasted to go from about $89 million in 2021 to an impressive $451, almost $452 million by 2033. And leading the pack with a 14.4% CAGR. I mean, the sheer scale of their EV production and their aggressive domestic market, it just means an unparalleled demand for efficient, high-volume testing solutions. Simple as that.
Scale matters.
It does. Japan also sees significant expansion up to about $195 million. They're leveraging, their really strong automotive engineering base.
Okay, and here's a real standout, I think. India. India shows the highest growth rate globally, a 15.481% CAGR, projected to go from just $26 million, roughly, in 2021 to nearly $148 million by 2033. What is driving such phenomenal acceleration in India? Is it just general EV adoption, or is there more to it?
India's surge is, it's fascinating. It seems to be driven by like a confluence of factors. You've got a burgeoning domestic market, for sure, but also a really significant government push for electrification, to think about things like the FAME scheme there, and also increasing localization of EV component manufacturing within India.
Local manufacturing.
Exactly. And that creates this powerful need for homegrown eDrive validation tools and, the expertise to use them. And of course, South Korea, Australia, Taiwan. They're also contributing steadily to this regional surge, often through innovation in specific areas like maybe batteries or power electronics.
Okay, that makes a lot of sense. Local needs driving local solutions. All right, shifting gears again. South America. The market there, it's set to grow from about $46 million in 2021 to nearly $200 million by 2033. That's a strong CAGR too, 12.95%. And Brazil seems to dominate the region, climbing to almost $90 million by 2033.
Yes, Brazil is definitely leading, largely because of its big existing automotive industry and, an increasing focus on EVs. But it's worth noting, countries like Colombia are also showing really rapid expansion, a 14.5% CAGR there.
Wow.
Yeah. So it demonstrates that the demand for these testing solutions, it isn't just stuck in the traditional auto manufacturing hubs anymore. It's spreading out. It's increasing broadly as more countries commit to EV adoption and start to build out their own sort of supporting ecosystems for electric vehicles.
Right. The ecosystem is key. Okay. The Middle East also follows with Significant potential, projected to rise from about $37 million in 2021 to $167 million by 2033. That's a CAGR of 13.3%. And Saudi Arabia seems to be leading the charge there, a 14% CAGR.
Mm. That growth in the Middle East, particularly Saudi Arabia, it really reflects a strategic move, doesn't it? Diversification away from oil-based economies. You see huge investment there in new smart cities, sustainable infrastructure, and that naturally includes a big push for electric mobility. So establishing robust local testing capabilities, it's just a critical step if they want to build out a self-sufficient EV ecosystem in those regions.
Yeah, building local capacity seems to be a theme. And finally, let's look at Africa. The market there is set to grow from about $27 million in 2021 to roughly $114 million by 2033, shows a CR of 12.2%, 12.3%. Nigeria and the rest of Africa seem to be the key drivers here, which probably reflects the emerging nature of the EV market in many of those nations.
It's exactly. Africa, yeah, it's starting from a lower base, definitely. But it represents just immense long-term potential. As EV adoption eventually increases and local assembly plants or even manufacturing plants start to emerge, the need for that foundational testing infrastructure is just going to grow exponentially. So it indicates these markets aren't just, importing EVs. They're actually starting to lay the groundwork for their own e-mobility future.
Okay, fascinating stuff. So bringing it all together, what does this really mean for you, the listener? We've seen pretty clearly that this global eDrive testing solutions market is experiencing, well, truly explosive growth, and it's fueled directly by that worldwide shift towards electric powertrains and, just as importantly, the rising demand for these sophisticated advanced testing platforms.
Yeah, and if we connect this back to the bigger picture, it's pretty clear that while, regions like North America and Europe, they remain strong, they're contributing, they're innovating. But the real surge, both in market share and especially in those highest growth rates, that's increasingly coming from Asia Pacific, particularly China and India. And that shift, I think, it signifies a kind of global rebalancing of where the core innovation and, crucially, the demand for these vital solutions are really located now.
Absolutely. I mean, India showing the highest growth rate globally, 15.5% CAGR. That's incredible. But as you said, let's not forget the adoption curve is also climbing pretty steeply in emerging regions too. South America, the Middle East, Africa. Manufacturers there are heavily investing in these test systems that support high-speed EV, drivetrain validation, diagnostics. It's just so clear this isn't some niche market anymore. It's a foundational piece, kind of unseen, but absolutely essential for the entire EV future, ensuring everything from performance right through to safety.
And this brings up, I think, an important question for you, the listener, to maybe ponder. As the world keeps racing towards electric mobility, and as these testing solutions inevitably become even more advanced, more integrated, how might their continuous innovation and expansion actually redefine what's possible? For EV performance, for safety, and ultimately for widespread adoption in the years ahead. It's really not just about the cars you see on the road. It's about this unseen, vital infrastructure that makes them work, makes them better, and eventually makes them ubiquitous.
Welcome back to the Deep Dive. Based on the sources you've given us, today we're going to pull back the curtain on something really vital for every EV out there, but something most of us just don't think about.
Yeah.
We're talking about the eDrive testing solutions market. Now, eDrive, that's basically the electric heart of the car, right? The motor, inverter, transmission, the bits that make the wheels turn.
Exactly.
And this market, well, it's all about making sure those electric powertrains are safe, efficient, and, actually deliver what's promised.
Right.
So our mission today is to unpack these sources, find the key insights, be some surprising facts, just to get you really well informed fast. How do you actually build trust in tech that's, well, evolving so incredibly quickly? And what are the hidden forces making it happen?
Well, what's really fascinating here, I think, is that it's not just about making cars go.
Yeah.
It's really about pushing the limits of what electric vehicles can do safely and efficiently.
Okay.
And the relevance right now is huge. Precise, real-time evaluation tools. They're absolutely critical.
So what kind of things are we testing?
Oh, it's comprehensive. Everything from motor efficiency, battery integration, torque generation, which needs to be spot on for a smooth ride,
Yeah, that jerky feeling is awful.
Exactly. And regenerative braking, too, getting that energy back to the battery seamlessly. And they test this stuff in simulations and in real-world scenarios. Because ensuring top performance and meeting safety standards isn't just like a nice to have. It's essential for staying competitive and building that all-important consumer trust.
Okay, so it's clear this testing is vital. What are the big forces really propelling this market, making these solutions so necessary right now?
Well, the number one driver, no surprise really, is the huge surge in EV adoption. More EVs on the road simply means more eDrives need testing.
Right.
But it's not just the number of EVs, it's also the speed, the accelerated product cycles in the EV world. Manufacturers are pushing out new models way faster than they used to.
Ah, so less time for testing.
Less time for the old, slow methods, yeah, which puts pressure on testing capabilities.
Okay.
And then, right alongside that demand, you've got really tough government regulations and quality standards.
Okay, the regulators.
Yeah, globally, they're enforcing super strict rules. Safety, emissions, energy efficiency, all of it. This forces manufacturers to prove their powertrains meet very precise benchmarks. And like we said, that's key for compliance, brand reputation, and ultimately trust.
That makes sense. But I wonder, does that sometimes lead to just, ticking boxes, meeting the minimum instead of truly innovating for safety? Or does it genuinely push them?
That's a really fair point. And sure, compliance is the baseline, but honestly, the sheer complexity of modern eDrives, especially with all the new tech, it often pushes them beyond just tech boxes.
How so?
Well, that brings us to another huge factor. The technology itself is just evolving so fast. Modern electric drivetrains are becoming incredibly complex systems.
Okay.
We're talking multiple motors, really sophisticated regenerative braking systems, even AI driving controls, and software over-the-air SOTA updates.
So the car software is changing while it's on the road.
Potentially, yes.
Yeah.
Which means testing isn't just about the physical parts anymore. It's about validating complex software algorithms that might be learning and adapting.
Wow.
It's like trying to test a car that's constantly getting smarter. How do you guarantee safety when its brain keeps evolving? It's a real challenge.
That adds a whole different dimension. So these evolving systems really demand more adaptable testing platforms.
They absolutely do. You need testing solutions that can handle deep customization, provide real-time data analytics, and integrate advanced digital twin simulations.
Digital twins,
Yeah.
like a virtual copy.
Exactly. We'll probably touch on that more. But the main goal here is helping the OEMs, the vehicle makers, bring reliable products to market much, much faster, which is critical in this space.
Okay, that paints a picture of rapid growth and complexity, but it can't all be smooth sailing. What are some of the biggest challenges, the roadblocks holding this market back, maybe?
Yeah, there are definitely hurdles. One of the biggest, the huge capital investment needed. Setting up these advanced eDrive testing environments is seriously expensive.
How expensive are we talking?
Well, think about it. You need specialized dynamometers, basically. Really advanced treadmills for electric motors to simulate driving.
right.
Climate-controlled chambers to test performance in extreme heat or cold.
Because batteries hate extremes, right?
Exactly.
Yeah.
Performance can vary wildly. So you need these chambers to simulate everything from, say, Arizona summers to Scandinavian winters. Then add sophisticated simulation software, high-speed data systems, a single comprehensive test rig. It can cost as much as a small fleet of luxury EVs.
Whoa. Okay, that's significant.
It really is.
Yeah.
And that high initial cost can be a major barrier, especially for smaller manufacturers or startups, maybe developing economies. It's not just the little guys. Even medium-sized companies can struggle with that kind of investment.
So if it costs that much to even get in the game, does that risk just a few big players dominating, making it harder for innovative smaller companies to compete?
It certainly can tilt the playing field, yeah. That's a real concern. And even if you can afford the gear, the complexity of the testing protocols themselves is another massive challenge.
How so?
Evaluating these drivetrains properly means really deep assessments. These like heat dissipation, making sure all the electronics work together without interference, electrical safety, all absolutely critical.
Okay.
The tricky part is accurately recreating all the variables of real-world driving inside a lab, but doing it fast enough not to slow down development. Getting that balance right is a huge technical hurdle.
That sounds incredibly complex. Is every test setup unique, or are there standards? And what does that mean for costs or timelines?
Many tests are highly customized for specific eDrive designs, which adds to the cost and the time, absolutely. And then there's the final piece, a very human one,
Yeah.
the shortage of skilled people.
Ah, the talent gap.
Exactly. eDrive testing needs engineers with very specific expertise. Motor control systems, embedded diagnostics, power electronics, software integration. It's a niche skill set.
And there aren't enough people.
The global talent pool is pretty limited, which means validation can get delayed and companies become more reliant on expensive outsourced help. Imagine a small startup with a brilliant EV design If they can't access these expensive test rigs and the people who know how to run them, their innovation might just stall out.
Yeah. Despite these pretty big challenges, innovation is still happening, right?
Mhm.
What are some of the exciting trends or shifts that are helping overcome these roadblocks?
Oh, absolutely. Innovation doesn't stop. One of the biggest trends is using digital twins and simulation-based testing much more.
Okay, the virtual copies again?
Right. These virtual models let manufacturers test eDrive systems under tons of different scenarios, all on computer. And it's not just about saving money, though it does that too. It's about finding potential problems, maybe flaws, that you just couldn't spot easily with only physical prototypes. Well, imagine identifying a critical issue with how heat builds up under certain conditions before you've even built a single physical part. That saves potentially millions in redesigns and could prevent recalls later on. You can troubleshoot problems before they physically exist.
That's incredibly powerful, fixing problems virtually. What else is changing the game?
Another big shift is towards modular and scalable testing platforms.
Meaning?
Well, EVs are incredibly diverse now, right? Different battery voltages, different types of motors, hybrid setups.
Yeah, it's not one size fits all.
Not at all. So manufacturers need testing solutions that can adapt easily to all this variety. Modular platforms give them that flexibility, that agility. It improves efficiency and cuts down on engineering overhead.
So adaptability is key. And I'm guessing data, just tons of data, is central to all this testing.
Huge amounts. And that leads us straight into the third major trend, integrating AI and machine learning.
Okay, AI in testing. How does that work?
Well, AI-powered tools are getting really good at analyzing the massive volumes of data coming off these tests. They can spot tiny irregularities, patterns that a human engineer might miss, and even predict potential system failures before they actually happen.
Predicting failures, that sounds huge.
It is. This kind of proactive approach leads to better performance, fewer recalls down the line, and just generally better management of the eDrive over its whole life cycle.
AI sounds almost like a magic solution here, but are there downsides? Any challenges in relying so much on machine learning for something as critical as vehicle safety?
That's a really important question. AI offers massive advantages, but yeah, challenges exist. First, the quality of the data AI learns from is everything. Garbage in, garbage out. Bad data means bad predictions, which could be dangerous.
Right. And then there's what some people call the explainability issue. Sometimes an AI might flag a potential problem, but figuring out why it flagged it can be really complex. You still need human experts to validate its findings. So yeah, it's not quite a silver bullet, but it's an incredibly powerful tool that, when used carefully, really does boost safety and efficiency.
So what does this all mean for you listening? It means the future of electric mobility, the EVs you see becoming more common, they're being built and tested right now in incredibly sophisticated ways you probably hadn't imagined. We've sort of pulled back the curtain on this eDrive testing solutions market. We've seen the challenges, the big costs, the need for specialized talent, but also these powerful forces of innovation and tougher regulations pushing it forward. Things like simulation testing, AI diagnostics, those flexible modular platforms. They're really changing the game for the long haul. And this isn't just, an abstract engineering problem. It connects to why maybe new EVs cost what they do, or why some cool new features might take a bit longer to actually reach the cars we can buy.
Absolutely.
Yeah.
And if we connect this to the bigger picture, that constant push for better, smarter testing, it isn't just about engineering specs. It's really about building reliability and fundamentally trust in these technologies as they change our world so quickly. It's kind of the hidden engine driving our confidence in the future of mobility.
Yeah.
And just a note, all the insights and data we discussed today came exclusively from Cognitive Market Research.
So maybe next time you see an EV quietly glide by, take a second to think about that invisible world of testing that made it possible, and maybe wonder, what other complex systems in our lives rely on similar, intense, behind-the-scenes innovation to make sure they're safe, reliable, and ready for us to trust completely, often without us ever knowing how much work went into it?